Let me know when you guys are ready.
I'm ready.
Okay.
Give me like 1 minute.
Sure.
2 seconds.
No problem.
You guys all got his email, right? That he sent us?
Yeah.
Okay, sweet. I'm pretty happy about it.
Yeah.
He's like, you guys have too much information.
Yeah, it's gonna make this next section, or next part, really easy, I think.
Yeah.
Yep. Yep.
Lots of stuff to pay. Okay, I'm good.
Okay. So number 3 is the third one.
Right. 4, I
Yes.
got the second one.
The second one? Okay, that's what I have.
Mhm.
Number 5. I don't remember. Let's see.
Okay.
I think the last one.
A plot of residuals.
Let's see.
So it's a scattered plot.
Yeah, if the points on the QQ plot are close to the line, we can conclude that the residuals are normally distributed.
Does anything about a zero mean?
That's what I don't know.
Plot, makeup. Represents the value.
I just don't think it's the other ones. Like, the other answers don't make sense as
Yeah.
well.
Yeah.
So I'm like,
There's
the last
no
one.
there's no pattern.
Yeah.
Because can the residuals, yeah, the residuals can be negative, so I don't know, it
Yeah.
has to be that one.
Yeah.
Yeah.
And there's
Alright.
no shape because they're scattered.
Yeah.
Sounds right to me.
So, math,
Oh
self,
no, we had to fill out our.
confidence
Okay.
as the explanatory.
I wish they'd give us a heads up we're having to open these files.
I know, right?
Yeah.
The pain.
What's the math self-efficiency?
Well, we'll give it a while there.
Okay. So our explanatory or X value is our confidence data, and our Y value or X-axis is the score data. So whenever that loads, because in lesson 22 it says that the independent variable is X, which is also called the explanatory variable, and the dependent variable Y is called the response variable. So we'll need,
Yes.
yeah.
Wait, what number are you guys on?
6.
Okay. I was like, what?
It's just telling us what to put into the thing.
Oh.
Compute the residuals. I gotta go back to the lesson to figure out how to do that.
This statement.
So residuals, analyze.
Analyze regression linear.
Linear.
Analyze
Yeah,
regression
so
linear.
sorry. Okay, so what's the dependent again? Sorry.
Let me go back. I forgot
Do you
already.
guys ever get errors and then it doesn't open the data?
Yeah, and then sometimes I have to go into the open file and find it.
Yeah.
Gosh, that's, yeah.
So confidence.
So our dependent variable was the score data.
Okay. That's what I thought. And then
Score is the dependent, and confidence
is
rating was the Y.
independent. Oh, and then do you have to click save and something? Is that this one?
If you want to save the residual values, do the following. Click on Save. Mark the checkbox for unstandardized residuals. Save. Unstandardized residuals. Click Continue and click OK. Continue. OK.
Holy crap. Okay. And we're looking for
The residuals will be saved in a new column in your SPS data file labeled residual1. Let's go back and look real quick and it shows it. Oh, it's a lot of files. So now that we have those, we probably want to make a scatter plot, right?
Oh, my program's just now opening.
it's all good. So residual statistics, I have a negative 38 and a maximum of 23. Is that what you have? Like the last
Oh yeah,
box, residual,
yeah, that's
and
right.
then the residuals.
Do we need that for one of the questions? Oh,
Well, what statement best describes the residuals? So the residuals are not all negative, and do they form a linear pattern? I guess, yeah, we'd have to create the.
yeah. So to create it, we go to Graphs, Legacy Dialogues, Graphs, Legacy Dialog. Oh crap. Legacy Dialog, Scatter Dot, Simple Scatter. Fine. The y-axis was our crap. I can't remember. So the y-axis was our response variable, which was the score data.
Mm-hmm.
Score data was our y. Confidence rating was our x. This is okay. Click OK. I mean, it follows a linear trend, but it's not very close.
Yeah.
We said our residuals were, let's see, negative.
I'm gonna say it's the first one, that they're between about negative 40 and 25.
How come it wouldn't be the last one?
I don't.
What are the requirements to form a linear pattern?
Mm. So,
'Cause I mean that makes sense. Negative 38 to 23, so it's almost. Yeah, I think it is. I don't know.
yeah.
Yeah, I'll go with A. So now we need to make a Q plot.
Um, yeah.
How do we do that?
Yay. Did you get like 5 graphs?
Let me see.
Or like QQ plots, I mean.
I don't remember how to do the Q plots. How do you do them again?
Oh.
It's graphs.
Um,
Oh wait.
I got it under analyze and then descriptive statistics, and then it's QQ plots. But I mean, maybe there's more than one QQ plot thing. But
You guys already make the graph.
yeah.
Okay, sorry. I'm like way behind here. I'm like trying to catch up.
That's okay. I'm trying to figure out what this. Yeah, I got a bunch of them too.
I just want to make sure that I have it down because then I would be like so lost.
Easy.
So residual.
I don't know.
I think it might be the last one. The residuals are fairly normal.
That's what I was thinking too.
Yeah. But yeah, did you get like 4?
Yeah, I got like 4 different things for it.
Okay, cool. Okay, and I'm pretty sure we're just looking at the top one there.
Okay.
And I would say, yeah. Use software.
QQ plot.
Where are you at now, Kelly? I mean,
Number
Karen.
8.
Sorry. Sorry.
Oh,
I made the. I did numbers. I can. What did I do? I did the analyze, compare, analyze regression. No, wait. Linear? I have a lot of windows. Oh no! So I did the whole regression thing.
Okay.
And then for the graph, do we just do the scatter plot? And then
Yeah.
that gives us the QQ plot thing?
You have to go into analyze, descriptive statistics, and then QQ plots for the QQ plot, and then
Oh. And then variables, you put in score and confidence rating.
yep.
Okay. Okay. And then you guys got all these little squiggly lines, like graphs.
Yeah.
Yeah.
1, 2, 3. Okay. So, what did you get for number 6?
Number 6, we got A.
A.
Mm-hmm.
Okay. Negative 40 and 25. Okay, yeah, makes sense. And did you get for the residual for 7? Is it the first one?
Um,
Well, my
I
first
think
QQ plot was like perfectly, like almost perfectly straight up and down.
Yeah, mine
yeah.
too.
I
So
mean,
I would
not like straight up and down, but like followed the line.
So which
Um,
one do you look at? You just look at the normal QQ plot?
I
I think
think
so.
so.
Okay, then in that case, it's fairly normal to me.
Yep,
Okay.
that's what I would say.
And then the scatter plot I made, no, I guess it doesn't save it. You guys already made your scatter plots, I'm guessing?
Yeah.
Okay. So I have y-axis, the confidence rating, and the x, the score.
Yes.
And then okay. And then they're kind of scattered all over the place. Check all that apply. Well, it's not the first one because there's no linear relationship.
Wasn't there like kind of a linear relationship?
I guess I should look at what a linear relationship looks like.
I think score is supposed to be your y-axis, and your confidence rating is your x. Sorry.
Oh, maybe I have it. Okay, I have it the other way.
Um, uh, what do you think, Micah?
So your score is your dependent, and your independent is your confidence rating.
Hmm.
So let's see. It says
Yeah.
independent. Yeah.
So your response variable is your dependent, and that's your y.
Yeah.
Yeah.
And the explanatory variable is your independent, and that's your x.
Do you think there's a linear relationship?
Independent. Okay, let me switch these up. I think that's my problem.
Excuse me.
I really don't know how you tell if there's a real linear relationship from looking at it.
I don't know. This stuff is not fun.
So if the linear regression is appropriate, then the residual plot will show no pattern and will consist of random scatter.
It says that if what?
So it says if the linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. If there is a pattern in the residual, it suggests the linear regression is not appropriate.
Hmm. Does that mean that there's no linear relationship?
That's
Mm,
what I think. Um,
So let's see. On the homework, it says assumption there is a linear relationship between x and y. How you check? Make a scatter plot and check visually for a linear relationship. Then make a residual plot as well. What you hope to see is a hot dog cucumber shape in the data. There should be no pattern in the residuals.
well, there's definitely no pattern.
Let me see what. Where's my thing?
I think I'm
My
just gonna
computer just
put
froze.
yes
Great.
for me. I'm gonna say sure, there's a linear relationship.
Okay.
And then I think the residuals are normally distributed.
Uh-huh, I think so too.
Um,
So which
and then
one? So did we say yes or no to A?
I went ahead and said yes.
Okay.
I don't know what to put.
Yeah, I mean, I could be wrong.
So the variance of the error terms is constant for all values. We check it by making a residual plot, and we hope to see no megaphone shape in the residuals. Did we see a megaphone shape in the residuals?
I see a
Mm,
blob.
I think so.
My, oh my gosh, SPSS just froze, so I can't really see what I made anymore.
None of mine have a megaphone, no.
Mine doesn't look like a, mine looks like a whale.
Okay.
That's
And then the x's are fixed and measured without error, cannot be checked directly. X's should be measured accurately and precisely. I don't know. How do we check for that?
Yeah, exactly. I don't even know. I mean, if this information does follow all of the requirements that are listed in the book, there should be a linear relationship between X and Y.
yeah.
Uh,
Uh,
and then what else? X's are measured without error.
Excuse
And
me.
observations are independent.
I don't know. I quit.
So, okay. Oh, I see. Okay. So the question, what it's asking us, like the options that it's given us, those are the requirements. So we need to check to see if, okay,
yeah.
Okay.
slow
Um,
connecting here in my brain.
so I want to say the first three are all correct. I don't know how to check the last two.
So it's in the homework and it says assumption. The observations are independent. How you check cannot be checked directly. And knowing the value of one of the y's tells you nothing about other points. So I
I
don't
feel
know
like
how we're
this
supposed to check
doesn't
it.
explain anything.
Yeah.
Yeah.
Maybe they're all yes.
Maybe.
I don't know.
Me either. Um,
Does your friend know?
yeah, where's your
Kelly?
friend?
I haven't asked them, but mm,
I'm still looking through the book to see if maybe there's something else.
yeah.
Does it want us to find for p-value? Because then that way, no, never mind.
I hate this so much.
Maybe we'll skip it and come back to it, and then maybe it'll be clear once we work the other problems.
Yeah.
What is B1? Beta 1. For the estimate of the slope. For the slope. B1 is
Let me know what you got. When I did it, I got 12.695.
Same.
But for some reason, my computer, there we go. Now it's deciding to work.
this is when you do the coefficients and it tells you the wait.
Yeah.
So you have to redo the whole thing.
It should have been on there already.
Already?
Yeah.
Oh, there it is. There it is.
So yeah, you got it by looking at the coefficients, right?
Yeah, it's the bottom one. It's
Yeah.
the 12.695.
Yeah.
Oh,
What
I
does
have.
the top mean?
Oh, 695. Okay.
Do you remember
For
what the
number,
top value means? Like what it's for?
what's that?
Do you remember what the top value means or what it's
Yeah,
used
that's
for?
the B0 value.
Oh, okay.
That's your y-intercept.
Gotcha. Why? Yeah.
So your constant is B0.
Yeah. But it's asking for B1, which is the bottom number.
I'm just writing it down for later. I'm sure we'll need it.
Um, Going back to question 8, it's the
Uh-huh.
first 3. I'm not sure why, but it is the first 3.
So that makes
Not
sense because it doesn't really tell us a way to check the other values, which I don't understand why it's an assumption then. Because in the textbook and in the homework it says those are assumptions and we can't really check them, so
yeah.
I don't know. Okay.
Anyway, it's the first 3.
Alright.
Um,
Sweet.
yeah.
Did you get 12.695 for number 9?
Yeah.
Yeah.
And then for number 10, I went and did the confidence interval and I got the first one.
Yep.
Okay. And number 11, since I think my p-value was 0.000, so it would be the second one, reject the null hypothesis test because the p-value is less than a.
Yeah, where do you see your p-value?
Yeah.
So it's in your thing, you gotta scroll over, it's in your coefficients.
Yeah.
Oh, so you.
Oh, and it's under the sig.
Okay, yeah. I'm just making sure I'm looking at the right stuff. But yeah, so it's the second one.
Yeah. And then for number 12, for a hypothesis test for B1 slope, if you reject the null hypothesis, what does it mean?
I'm sorry, what was 12?
I'm not sure.
Oh, that was 11 you were saying? The second one?
Yeah. Yeah. Number 12, if you reject the null hypothesis, what does it mean? I don't know.
Well, if you reject the null, that means
That it equaled 0, right?
yes, less. Was it the first?
So since 0 is not in the confidence interval, we can say that B1 does not equal 0. And so the
So the
regression, yeah, so I think it's the third one.
okay.
The third one?
Yeah.
Okay. And then for number 13, I got body length for the dependent variable.
Yeah.
And for number 14, would it be the second one?
I said the first one.
Oh, okay.
Mhm.
Do you know if that's what your friend got too?
Yeah, I already submitted mine as well. I just did, and
Oh,
it's the first one.
okay. Alrighty.
Any questions? Or you submit?
Nope, I got
How
it.
would you know? How would you know that it's the first one? Is it just because that's this type of hypothesis testing
For 14?
for 14? Because isn't it usually the second one for other ones?
Um,
Like in previous questions we've had?
I think it might have been, I think it mentioned that in the reading somewhere. I think
I
I remember reading about it,
Yeah. Okay.
but I don't remember because that's what I was thinking initially the second one for that same reason.
Mm-hmm.
So I
I
think
just
I'm gonna have to
in
go
my
back and look at
notes
the
that
reading again.
yeah, in my notes I just wrote down that since 0 is not in the confidence interval, we can say that B1 does not equal 0. And so, since looking at it since the confidence interval does not contain 0, we can say, like, that's a for sure um, statement, I guess.
But
Okay.
that's only with this type of hypothesis testing.
Yeah.
Okay.
Ugh.
Almost there, guys. That was the last new information, though,
Yeah.
if that makes it easier.
I can't wait till to take that comprehensive test.
Oh my
Oh, no.
goodness. Don't even.
I just want to cry.
Seriously.
Do you guys just want to talk about our paper on Thursday?
Yeah.
Yeah.
Okay, I'm okay with that.
Yeah.
Okay.
Alrighty. Well, good hustle, everyone.
All right.
See
See you
See you
guys.
guys.
you Thursday.